All right, so we're going to continue, and we were at number 5 of quiz 12. So we're going to start there, and hopefully the pen is working properly. So now this one is a funny looking one because it looks kind of like the difference of two perfect squares, but clearly 7 is not a perfect square, neither is 8. So that's a hint that we probably have to take out a common factor. And 7 is not a common factor, neither is 8. But if you look carefully, p is a common factor. So we can take out the p. And so we have here p. And then we divide that by p, and we get 7p. And we divide that by p, and we get minus 8. And so that is equal to 0. So we factored it, but we're not done. So how this works, when you have two things being multiplied, we have this being multiplied by this, and the answer is 0. So either that has to be 0 or that has to be 0. So we have two equations from that. Either p is 0 or 7p minus 8 is 0. And well, that's actually already solved. P is 0, or well, that part is not solved, so we can go ahead, add 8 and add 8. We get 7p is equal to 8, and then divide by 7, divide by 7. P is equal to 8 over 7. All right, and so that is how we take care of that one. Now, this is the hardest type. So if you see one that looks like that, then you either have to do trial and error or a diamond box. But before we go ahead and do either one of those, let's go and make this equal to 0. So we have to take 2v from both sides and take 5 from both sides. And the reason I'm not pulling that one over there is because I don't want a negative 3v squared. So I have here 3v squared minus 2v minus 5 is equal to 0. So now we could do trial and error. And actually, since you've seen me do diamond box before, I'm going to go ahead and remind you about trial and error because it's kind of important to know how to do that too. All right, so we have 3v and we have v. So all I did there was break 3v squared into its factors. So 3v and v. So now it's time to break negative 5 into its factors. So negative 5 could be factored in a number of ways. I could have negative 5 and 1. I could have 5 and negative 1. I could have negative 1 and 5, and yes, the order does matter. Or I could have 1 and negative 5. So the way trial and error works is I would try to figure out which one of these combinations make the most sense, and I would just do a guess, and then I would FOIL to check. Now, I don't really have much space or much time, so I'm going to guess the correct answer just to save some time. So I believe this is the correct answer, but we should always check. Minus 5 plus 1. So if we're foiling to check, we do first, outer, inner, last. So I'll do it over here. First, 3x squared, outer, sorry, not x, that's a v, but outer would be plus 3v. Inner would be minus 5v. And it already looks like we're going to get what we want to get, minus 5, which is in fact what we were hoping to get, which is our minus 2v in the middle. Hopefully that makes sense. If not, you can do the diamond box, but trial and error is also very useful. All right, so now we have two expressions here being multiplied. That expression is being multiplied. The answer is 0, so that times that gives you 0. So one of these have to be 0. So either 3v minus 5 is 0, or v plus 1 is 0. And going ahead and solving both, add 5 to both sides, divide 3. We get, I'll put it over here, v is equal to 5 over 3. And that is just one of our two answers. Or v is equal to, looking at this here, v is equal to negative 1. And that's our second answer. All right, let's keep going. So again, we're going to always make the equation equal to 0 first. So we have x squared minus 12x plus 32 is equal to 0. I brought those two over to that side. Now we're looking for two numbers that multiply to give you 32 and add to give you negative 12. And so we have to factor. We get x on one side, x on the other side. and we have x minus 8 and x plus, nope, x minus 4. And those two numbers multiply to give you 32, positive 32, and add to give you negative 8. And that's equal to 0. So that means x is either equal to 8 or x is equal to 4. And those are our answers. Kind of cross them out there. All right, so let's make this equal to 0 first, as we've been doing. X squared minus x minus 30. So two numbers that multiply to give you negative 30 and add to give you, there is an invisible 1 here, and add to give you negative 1. So we're going to separate our x's. And so the two numbers that multiply to give you negative 30 and add to give you negative 1 are minus 6 and plus 5, which means that either x is equal to 6 or x is equal to negative 5. And those are our two answers. And that's quiz 12. And we're going to keep moving forward. All right. So here is where we finished up our what was that? Our polynomials unit, and we're factoring and we're solving. And we went on to multiplying and dividing rational expressions, and then eventually solving rational equations. All right, so the first and most important thing that you should know here is that we cannot just cross random things off when you see fractions. We can only simplify by crossing off common factors. So when you see this expression here together, that is a factor of this entire numerator. X plus 4 together is a factor of the entire numerator. X is not a factor, it is a part of a sum. Together, that is one expression. Together, this is one expression. So an expression, so if you have a plus sign, whatever is on the left and the right of the plus sign is not a factor. It has to be multiplied. I hope that makes sense. So with that said, now we can start cross-canceling things. So for example, there's an x plus 1 over here, there's an x plus 1 over here. We can cross off those factors. There's an x plus 2 over here, and there's an x plus 2 over here. We can go ahead and cross those off as well. And then we're left with just x plus 4. And that's actually our answer. We have simplified. All right, so there we go. All right, so here we have a division sign. So you have to always remember, if you have a division sign, you're going to always want to keep the first, I say K for keep, the first fraction, change our division sign to a multiplication sign, and flip, so keep, change, and flip, the second fraction gets flipped to the reciprocal. So let's rewrite that, but keep, change, and flip the expression here. So 2x plus 1, just rewriting the first fraction, or as we said before, keeping it. 2x plus 1. Change, I'm changing my division now to a multiplication. And I'm flipping my second. So 2x plus 1 over 10 times x plus 1. Now, when you're simplifying these expressions, always remember that you should also factor whenever possible. So in this case, that's actually already in factor form. So is that. They're all in factored form. This cannot be factored, so this is also perfect. Now, question to you to think about, is 2x a factor, or is 2x, can it be cross-cancelled? Absolutely not, unless we are crossing off all of this expression, 2x plus 1. All right, so, but we can, so 2x plus 1 can go because there's 1 down here. We cannot double cross it off, so since we already crossed off 2x plus 1 over here, we cannot then cross it off up here. Now there's an x plus 1 over here, so we can cross that off as well as that. Now 5 and 10 have a common factor. The common factor is 5. It goes into 5, it goes into itself once. It goes into 10 twice. And I think we've crossed off everything that we can cross off. So at the top, we are left with 2x plus 1. Only one of them is left. And at the bottom, we're left with a 2 here and an x plus 3 here. And of course, we always like to write our coefficients first, so we write that way. And that is our answer. All right. So then it starts looking a little harder because this is not factored, neither is this. But remember, always factor whenever you can. And when you're factoring, always start off by taking out a common factor. So in the top, in the case of the numerator, a common factor here is 4. So we can take that out. We get 4. We divide everything by 4. We get the p plus 5. And then at the bottom, common factor is still 4. We divide everything by 4. We get p squared minus p minus 30. That actually can be factored further. So this is a division, so we're going to keep change flip that we kept that. Let's change this to a multiplication. And then let's flip this and we get 2 over p minus 6. All right, let's factor this because it can be factored and we always want it in factored form so we can start crossing things off. So here we have 4 times p plus 5. We already factored that, so I'm just rewriting it. And 4. Now we're looking for two numbers that multiply to give you negative 30 and add to give you that invisible 1, negative 1 right here. And my two numbers look like some version of 6 and 5. Yes, it is. It is p minus 6 and p plus 5. And we're multiplying, and I'm just going to keep it now because I've already flipped it. We don't want to flip it twice because that would be bad. All right. So p minus 6, we can't just cross off a p because it's separated by a subtraction sign. The term is the p minus 6 together. All right, so there's a p plus 5 and a p plus 5 at the top and the bottom, numerator and denominator. We can cross those off. There's a 4 in the numerator and the denominator. We can cross those off, 1 and 1. All right. Now, people are often tempted to cross off p minus 6 and p minus 6, but they're both in the denominator. We cannot do that. So the answer is actually 2 over p minus 6 times p minus 6. And that's as simple as this one can get. All right, so moving over here, again, remember, whenever you can, you always want to factor first. So we can factor this, so we should. And so at the numerator, we're looking for two numbers that multiply to give you 8 and add to give you 9. Those two numbers are 8 and 1. So we've factored it with m plus 8 and m plus 1. Now the bottom is already in factored form. There's nothing really else here. And we're multiplying it by 8 over m plus 8. Now, again, remember, m is not its own term. Neither is 8. M plus 8 together makes a term. Same with m plus 1. Together makes a term. All right, so we can go ahead and cross off m plus 8 and m plus 8. 1 and 1. We can cross off m plus 1 and m plus 1 because they're both in the numerator and the denominator. And we actually have only 8 left, and 8 is actually the answer. All right, so I think that might be it for this quiz. Yeah, that's it for this quiz. All right, so here we have the need for a complex fraction. And so I'm just going to make one up because I don't have one prepared. A complex fraction is something that looks like this. Let's say you have 1 over x plus 1 over x squared over, let's say, 5 over x. And I just made that up, and it could be the most ugly thing. I don't know how it's going to work out, but let's see. So I want you to remember that this big fraction bar right here just means divide. So we're actually going to have to divide some stuff here. But before we do, we're going to have to take care of the top. And if there was something else here, we would have to take care of the bottom, so on and so forth. So this really says, and I'll separate it here, 1 over x plus 1 over x squared divided by 5 over x. All right, so we want to first add. So we want a common denominator. The common denominator is the lowest common multiple, which in this case is x squared. So I would have to multiply the bottom by x, and the top by x, so that I can get that common denominator, and whatever I do to the bottom, I have to do to the top. So I will have x over x squared plus 1 over x squared, and it's still in parentheses, divided by 5 over x. All right, now we're almost there. Since we now have a common denominator, we can throw that there. And at the numerator, we have x plus 1. And then it's divided by, but since it's divided by, we're going to do a keep, change. So we're going to change this to multiplication and flip. So we're going to change that to x over 5. All right, this is not as messy as I thought it would be. So now we can go ahead. We can remember that x squared is just x times x. So we can cancel x as a factor and then cancel that. If you don't know how that happened, just remember again, x squared is really x times x. There was an x over here. So I basically just crossed off one of the x's there and one of the x's there. Hopefully that makes sense. If it didn't, then use the laws of exponents. The laws of exponents say you have to subtract. So hopefully something makes sense there. All right, so now we have everything as simplified as it can get. Remember, we cannot cross off that x with that x because together x plus 1 is one term. We cannot take it away from there. All right, so we have now x plus 1 over x times 5. So I'm just going to say times 5 there because that's just a coefficient, and that's the answer. All right, so that's how the complex fractions work. We do just so you know, we do the top. By do, I mean simplify. We simplify the top. We simplify the bottom, if necessary, and we divide the top divided by the bottom. Numerator divided by denominator. And you just take your time, get through the question. All right, moving on to quiz 14. This quiz is very tiny font. So there we go. All right, so now we are moving on to having to add, which is interesting because complex fractions came before. We just had to add something, so maybe you already know how to do this, but let's do it anyway. All right, so the first thing is you always want a common denominator. We have a 4 here, we have a 5 here, and we're looking for the lowest common multiple between 4 and 5. So the lowest common multiple in this case, hopefully you know it, is equal to 20. All right, so we're going to have to multiply the denominator by whatever we need to multiply by in order to get to 20 in both cases. I'm going to rewrite this because that is super duper tiny. So 5x plus 1 over 4 plus 3x plus minus 1 over 5. So I'm trying to get to the denominator of 20. So here I'm going to have to multiply by 5. That will get me up to 20. And also the top I'm going to have to multiply by 5. But on the other side, I'm going to have to multiply that by 4 in order to get to 20. And I'm going to multiply that by 4 in order to get to 20. I mean, well, not in order to get to 20, but whatever I do to the bottom, I have to do to the top as well. All right. So now our superpowered distribution skills is going to take us through the rest of this problem. We're going to do a little backwards here. Okay, so 5 times 5x gives us 25x. 5 times 1 gives us 5, and that's over 20. That is supposed to be a 5. It does not look like one anymore, but trust me, it is. Okay, plus 4 times 3x gives us 12x minus 4. All right, and that's all over 20. Now that we have a common denominator, we can actually join our numerators. So we get 25x plus 5, and I'm just rewriting there, plus, and I'm just going to rewrite here as well, 12x minus 4 all over 20. And we can simplify that by joining like terms. So 25x plus 12x should give us 37x And 5 minus 4 should give us plus 1. And that's all over 20. Now, everything is as simple as it can get. And that is our final answer. All right. Now we actually already have a common denominator here, PM and PM, they're common. But I think the trick to this question was the fact that we are subtracting here. So let's go ahead and do it. So 7P plus M over PM minus 3P, so I'm just rewriting because it is super duper small, over PM. And now we can put it all over the common denominator, which is PM. So we have 7P plus M minus, and everything is being subtracted. So I'm going to put that in parentheses. 3P minus 4M. All right, so that minus sign will actually change that to a minus and change this to a plus. It will change all the signs over on this side within the parentheses. And that is the trick to this question. So we actually get 7P plus M minus 3P plus 4M all over PM. All right, so now we can join our like terms. We have 7P here and negative 3P or minus 3P here. So we get 4P and we have plus M plus 4M. So we have plus 5M over PM. Now there are no more like terms. There is nothing in common in the numerator and denominator. Again, remember we cannot just say cross off P and then P here because this is an entire term and that's an entire term. I put parentheses just to show that to you. They are not required. The final answer is actually just 4P plus 5M over PM. And that's how we do that one. That's how we add that one. So subtract. Okay. So this quiz kept going. It's a little bit long. Here we have, I'll rewrite because again it is super small. My calendar decided to make an appearance. I don't think it's going to disappear, which is weird. All right, hopefully that doesn't bother me too much. Oh, it went away. All right, so R plus 2 plus 3 over R minus 3. All right, so when we have something like that, in order to find the common denominator, it's not the same as the questions we've just done. We actually just have to figure that our common denominator is one thing times the other. All right, so I'm going to write that over here. Our common denominator is R plus 2 times R minus 3. All right, and in order to get the common denominator here, we're going to have to multiply this side by R minus 3. And as you know, whatever you do to the bottom, you must do to the top. So on this side, we have, and I'm going to switch places here because we love to see those numbers in front of the parentheses. Doesn't matter that much, but I just like to see it that way. All right, so that's that fraction here. This is that. And we're going to do the same thing over here for the R minus 3. In order to get that common denominator, we have to multiply by R plus 2. So R plus 2 here. And as you know, whatever you do to the bottom must be done to the top. So we're also going to multiply by R plus 2. And we get here 3 times R plus 2. That should be 2. All right. And now we can use our super fancy distribution skills here as well as here. And we get on this side 5 times R, 5R, minus 5 times 3, so minus 15. I'm going to join everything together, plus 3 times R, and that should be a plus sign, 3R, 3 times 2, plus 6. And I don't know why I don't have what I need to have here, so let's just go ahead and fix that. All right. Okay, so then we have at the bottom r plus 2 times r minus 3. And now, common like term, 5r plus 3r gives you 8r minus 15 plus 6 gives us minus 9. And that's all over r plus 2. And my pencil or my pen is getting tired again like it did before. So strange. It's like it has feelings. All right, r minus 3. All right, and that is our answer for question 3. And we're going to keep it going until my pen decides to quit. All right, so here we have p to the third and m to the fourth. We also have p squared and m to the fifth. All right, so remember that p to the third is really, and this is just a side note, p to the third is p times p, and p squared is p times p, and the lowest common multiple of those two, well, can't be this, it has to be this. So the higher of the two, so the variable with the higher exponent is the lowest common multiple. I won't get into a long description of why, but just remember the variable with the higher exponent of the two is the one with the lowest, is the lowest common multiple. All right, so in that case, looking at p to the third and p squared, the lowest common multiple there is the p to the third. Looking at the m to the fourth and the m to the fifth, the lowest common multiple there is m to the fifth. And that's all we have. So here, let's make this bigger slightly. There we go. All right. So here, in order to get to p to the third, m to the fifth, we would have to multiply this denominator by m. So we would have to multiply that by m. What we do to the bottom, we do to the top. So here on the left side, we get m. And now, for the other fraction, we're trying to get this to p to the third, m to the fifth. So we would have to multiply by p. Whatever we do to the bottom, we do to the top. So we get, well, we already know at the bottom we want p to the third, m to the fifth, but at the top we have 7mp. All right, now to join the two, we have p to the third, m to the fifth, and it's m plus 7m